All right, let's go ahead and take a look at a full example for demonstrating the binomial random variable. So here's example 3 in our notes, and it says that people often avoid seeking medical care even when they suspect it may be necessary. So the main takeaway is that this example claims that approximately a third of respondents in a recent US survey reported avoiding the doctor. And it actually goes on to detail the results of a study titled "Why Do People Avoid Medical Care? A Quantitative Study Using National Data." And that's linked here. So if you just notice how if I hover on this, there's a little link that shows up down here. So you can actually click on this and be taken to this study. So let's go ahead and read on what happened in this study. So even individuals with major health problems who are experiencing symptoms avoid medical care. For example, in one study, 17% of patients diagnosed with rectal tumors, so it sounds pretty serious, reported that they waited a year or more to seek medical consultation after noticing symptoms, with some waiting up to 5 years. So notice this is after noticing symptoms. Avoiding medical care may result in late detection of disease, reduced survival, and potentially preventable human suffering. In this example, suppose that we randomly select 25 individuals and we are interested in the number of them who will agree that they have avoided seeking medical care in the past. So this is more or less our scenario that we have. And the first thing that we are asked is, you got to explain why this experiment is a binomial experiment. So I'm going to go ahead and list this out as best as I can from the top of my head. One of the first things that comes to mind is that we have yes or no responses. So that's mutually exclusive outcomes. And I'm going to go ahead and check that off because we do have yes, no responses, right? Either people are going to agree that they have avoided seeking medical care, who will agree that they have avoided seeking medical care. So the answer to that is yes or no. Next, I'm going to go ahead and assume independence. So is every trial, every individual independent of the next? We're going to go ahead and check that off yes, because this was a simple random sample, and the whole point of SRS is that we are going to get a representative sample. One of the last requirements is you have a fixed number of trials, fixed number of times that you're going to get yes or no responses. And so we can check that off as well. Now, fixed number of trial means that I'm only going to ask a certain number of individuals. And we already know this because we're selecting 25 individuals. So that's how I know that there's going to be 25 trials, 25 opportunities for yes or no. And we also have the yes response. So notice here, who will agree? We're interested in the people who will agree that they have avoided seeking medical care. And here we were told that 17% of individuals. So the probability of a yes is 0.17. Remember, the probability of a yes is called P. All right, now there was one final one, but this more or less takes the cake. And that was, I'm going to put it in parentheses. I'm going to put that you always have the same probability or equal probability for responding with a yes. So equal probability of success. So every individual that we're going to ask has the probability of 0.17 of responding with a yes. All right, now let's go ahead and define the random variable of interest for this problem. So what is the random variable of interest? If we look again, we're tracking the number of them who will agree they have avoided seeking medical care. So we're going to say that X, the random variable X, equals the number of individuals who will agree or who will say they have avoided seeking medical care in the past year. Awesome. Now, this does say write the distribution of the random variable. And this essentially just says, what do you know about this random variable X? And according to part A, this is a binomial experiment. So if I'm tracking the total number of successes, right, the number of individuals who will say they have, then X is binomial. So I'm going to say that X has a distribution that is binomial, where N, the number of trials, is 25, and P, the probability of success, is 0.17. So that's how we write the distribution of the random variable. And finally, D, find the probability that the number of individuals who avoid taking medical care in the past is at most 5. So this is relatively simple. We're going to write the probability that X at most means no greater than 5. So X is less than or equal to 5. And I'm just going to put a little box right here. So all of these probabilities we're going to find using StatCrunch. Remember that as soon as you know that the random variable has a name distribution, this becomes very simple because we simply go to Stats, Calculator, and you select the name distribution, which in this case is binomial. At this point, we go ahead and say, what is N? So there are 25 trials. And then what is P? So P is 0.17. Press enter, and lo and behold, you can see on your screen that we already have that probability statement, and this calculator calculates that. So it's adding the probability that you'll get 0 successes, 1 success, 2 success, 3 success, 4, right up to 5. So the answer is 0.7575. All right, and all of these probability questions are just as easy. We simply write our probability statement and then go ahead and throw it into StatCrunch. So I'm simply going to write the probability statements here. So the next part, find the probability that the number of individuals who avoid taking medical care in the past is between 5 and 7 inclusive. So you include 5 and 7. So this says, what's the probability that my random variable will be between 5 and 7? Random variable is capital X, just like that. All right, now this one's a little bit different because we noticed that probability of X being between 5 and 7. So the calculator here only has one inequality symbol. So what we do is we switch this standard to between. Clicking on between brings up two numbers, two boxes for us to adjust. So we're going to go ahead and adjust that to 5 and 7. And there you go. You can visually verify that it's counting 5, 6, and 7. So the probability is 0.3745. Awesome. Let's go ahead and wrap this up by finding the mean standard deviation of the total number of individuals who will avoid taking medical care. So the total number of individuals who will avoid taking medical care, that's random variable X. So they're simply asking what is the mean of a random variable and what is the standard deviation of a random variable. Okay, so the mean when my random variable is binomial is n times p, and the standard deviation is the square root of n times p times 1 minus p. Go ahead and substitute the corresponding values, and you will get your answer. So n is 25, p is 0.17, and that gives me 4.25. Standard deviation, same thing. Go ahead and substitute the corresponding values. So I'll let you find this one. And remember that you may want to use the decimal scientific calculator to compute this because it just makes it a little bit easy. So go ahead and find this one and type in your answer. All right, now G says interpret the probabilities and expected value. So let's maybe do a probability for D, and then we'll interpret the expected value. So for D, we have that the probability that my random variable X, the total number of individuals who say they've avoided medical care, being less than 5, is 0.7575. Remember that you want to take the frequentist approach and say that this means if we do 100 trials, so if we perform 100 trials, we expect an average, or sorry, not average, a total So you're basically going to take the probability and multiply it with the number of trials. So multiply the probability by the number of trials. So that's these two numbers. If you do that, you're going to get 75.75. So if you perform 100 trials, we expect a total of this many times that we observe, total number of like 75 or 76 trials resulting in 5, or I'm just going to put at most 5 successes. If you do 1,000 trials, then you will get roughly 757 or 758 of those 1,000 trials, resulting in at most 5 successes. So that's the frequentist interpretation of probability. All right, now let's go ahead and interpret F, the mean. Oh, F. So the expected value of X being 4.25. So what this tells me is that if I repeat the experiment many times, so if I repeat or perform 100 trials, I expect, so let's multiply that by 100. So we'll move this twice. Wait, 4.25. I expect 425 successes. So over 100 trials, there's going to be a total of roughly 425 successes. This means that there's an average of 4.25. So there's an average. There are 4.25 successes per experiment on average. All right, and there you have it. We have a complete example for the binomial random variable. So this is the kind of questions that you need to be able to answer for this final section for unit 3.2. Awesome. The next unit, we'll explore continuous random variables. Thank you for joining me. I'll see you in the next video.